Let me repeat. I am talking about case 1. m1 and m2 are equal. Two objects having equal masses, and the second body is stationary. First body is approaching to the second body with the velocity u before collision. After collision, what happens? I will tell you. The first body is stationary, the second body will be moving. After collision, this one will be moving, but the first body will be stationary there. I will explain with the help of the formula. So if the two bodies are equal in size, equal in mass, what happens is, this is during collision. Okay, this is during collision. They are just hitting. So initially the first body was having velocity u. After collision, the first body becomes stationary. The second body will be moving with the same velocity u. Meaning that the velocity of the first body simply transferred to the second body. After collision, the first body becomes stationary, but the second body will be moving with the u. So velocity of the first body is simply transferred to the second body, provided if the both the masses having if both the body having same mass. Let me complete it. After that you can ask me doubts. You will get time to ask me doubts. So how to derive it? We have a formula v1 equal to m1 minus m2 by m1 plus m2u. Let me write that formula. What is that formula? V1 is the velocity of the first body after collision. What is that formula? m1 minus m2 by m1 plus m2 into u. All these steps to be mentioned in your answer paper. Okay. If they are asking for case 1 and case 2. V1 is the velocity of the velocity of the first body after collision. What is the velocity of the body after collision? V1 is the velocity of the first body after collision. m1 and m2 are equal. So m1 is m here, m2 is also m. M minus m will be 0. It will be 0. Meaning that the first body is stationary. First body becomes stationary after collision, because the final velocity of the first body is 0. Meaning that after collision, the first body stationary. What happens to the second body? The final velocity of the second body. I will repeat, don't worry. You can ask me doubt after this explanation. V2 we have derived the formula. You better memorize this formula. 2m1u by m1 plus m2. V2. 2m1u. 2m1 by m1 plus m2 u. We derived in the last class. Here m1 and m2 equal to m. So m1 is m, m1, m2, m2 both are m. Two m by 2m. Is it correct? 2m by 2m is 1. 2m by 2m is 1 u. Meaning that the second body is moving with the initial velocity of the first body. Let me write the conclusion here. Initial velocity of the first body after collision. Initial velocity of the first body. This is I am talking about the after collision, right? So after collision, first body comes to rest, but the second body is moving with the initial velocity of the first body. This is case 1. What is this case 1? If both the body having same mass. Okay, case 1 is this, same mass, both the body having same mass. If you have played caroms games, you can understand that the first coin comes to rest, the second coin will be moving. Okay, so all of you please write down. If you don't understand any step, please ask. If you don't understand any step, please ask. And remember, these two formula you please memorize. In exam, if they are asking for this case 1 or case 2, you must have this formula. You must have this formula. So you please memorize the formula of V1 and V2. It is very difficult to derive it again. If they are simply asking for case 1 only, you may begin with this formula. Okay. Devasri understood. If you have written and clear, raise your hand. If you have written and clear, raise your hand. Devasri, Aaron, Rakshana, say the understood. Okay, everyone is okay. Now I am talking about case 1 is clear. Think about the caroms games. Okay. Case 2, the first body is very, very small compared to the second body. Case 2 is what? The first body is very, very small compared to the second body. Think like this. The first one is just a very small stone. Understood? Stone like body. Very small thing. But the second one is a huge rock. Understood? I mean, they are elastic. Sorry. Both of them are elastic. No energy loss happens. The first one is very smaller body. Very, very small. But the second one is a huge body. Then only M1 will be very, very small compared to M2. Understood? In this case, what happens? This is before or after collision. During collision, they are going to contact. There is a small contact. Okay. This is during collision. What do you expect after collision? Anybody? What do you expect after collision? First one is very small. The second one is a huge body, larger in size. If the smaller body comes in contact with the second body, what do you expect? You don't know? I will explain that. The first smaller body will be rebound backward. The second body will be going backward. Understood? Just like that. For example, there is a wall. Wall will have a certain mass, right? The wall, rock, okay, thing like that. There is a wall. It is a huge mass, right? If a rubber ball is thrown, M1 is very small compared to the mass of the wall. You agree with me? If the ball is thrown into the wall, what happens? Do you believe that the wall and ball, both of them will be moving forward? No. The wall will be stationary. The wall is a huge body having very large mass. It will be almost stationary. But the rubber ball, elastic body, right? The rubber ball will rebound. It go backward with the same speed. Initially, if it is approaching with the velocity speed u, it will be rebound with the same speed u. We are not considering any energy loss. I am talking about elastic body. Elastic means that there is no loss in energy during collision. So whatever speed the first body approaches, in the same speed it will be rebound. So that happens here. That is drawn here. M1 is approaching with the speed u. After collision, M1 will be rebound, go backward with the same speed. You understood? Devasri, Aaron, Rakshana, Said, all of you clear?
Yes, sir.
Yes, sir.
But how do we derive it? How can we derive it? We expect this, there is no doubt. But how can we derive? How can we derive it? Yes, using formula. What is the formula? V1 equal to M1 minus M2. Yes. but you better memorize the formula. Using formula I am deriving. Okay, what is v1? v1 is the velocity of the first body. v1 is the velocity of the first body after collision. We have a formula m1 minus m2 by m1 plus m2 into u. m1 is very large. Sorry, m1 is very small. This is actually velocity. Okay, no problem. They are vector quantity. m1 and m1 is very small, m2 is very large. For example, let me explain with the help of an example, then only you can understand. m1 is very small, let it be 1. m2 is very large, let it be 1000. If I don't take any numerical example, you cannot understand it. That is why. m1, take some example, you will get the value, don't worry. Let us take m1 is very small value, say 1. m2 is very large compared to m1, let it be 1000. I'm explaining this with the help of a numerical example. This is just an example. Okay, m1 is 1, m2 is 1000. m2 is very large, understood, into u. Numerator is minus 999. Minus sign will be there if you subtract. Denominator is 1001 into u. Approximately, if you do the division, 999 by 1001, approximately 1. If you have the calculator, you can check it. 999 by 1001 is approximately 1. Minus 1 into u. Approximately minus 1 into u or minus u. Is that correct? So v1 equal to minus u. What does it mean actually? Minus sign indicate that the final velocity will be towards left side. v1 having negative sign indicate that the final velocity will be towards left. That is the meaning of negative sign. The magnitude is u itself. Initial velocity of m1 is u, but final velocity will be minus u. Minus sign indicate backward, left side. So approximately minus u. If I don't take any numerical example, you cannot understand. That is why. So it is clearly here in bracket you may write, show this example. So you may write like this, okay, minus u. Okay. So v1 equal to minus u means that what is our conclusion? The first body rebound, understood, with the same speed. First body, the smaller one, right, rebound or move backward with the same speed. This is the conclusion about the first body. All of it clear? Devasri, Aaron, Rakshana, Raj, everyone said you understood.
Yes, sir.
And what about the second body? What about the second body? The second body is stationary. I will tell you the reason why the second body is stationary. The final velocity of the second body. You please memorize in exam, either they will be asking case 1 or case 2. In that case you must have the formula in your hand. Yeah, otherwise you have to derive it. Derivation will take too much time. So better you memorize the formula. Okay. This is the formula of V2, right? V2. What is M1? M1 is very small. You may take some numerical example for that. Or numerator is very small compared to denominator. Or you may take some numerical example if you have any confusion. 2 into M1 is 1, like previous example. M1 plus M2 will be 1 plus 1000. M1 is 1 kilogram, M2 is 1000 kilogram. 2 by 1001, is that correct? 2 by 1000 is very small, correct? 2 by 1001 is 0.00, like that. 0.00 something into u, approximately 0, right? This is just an example. Okay. Okay, understood. So V2 is almost 0, meaning that the second body is almost rest. Understood? Second body is at rest after collision. So the reason also, I mean, the conclusion you have to write. So all of you please write down. To make you understand, I have taken a few numerical examples. So all of you please write down. Case 2. Case 2 is the first body is very very small. Mass is very very small compared to the mass of the second body. So all of you please write down. If you are okay and written, raise your hand. The Aaron understood. Rakshana okay. Devasri Said understood. Raj okay. So elastic collision is over now. This is a one-dimensional elastic collision. Why one-dimensional? Because the body moving in the same line. Understood? The body is moving along a same line. One body is not going like this, other one not going like this. Understood? The motion will be along the same line. That is, it is said to be one-dimensional elastic collision. Okay. Okay, one-dimensional elastic collision. The derivation is over. Okay. The next is by today's class this chapter will be over. Okay, by today's class this chapter will be over. Another derivation is there. One minute. All these derivations are there in textbook. If you refer the NCERT, you can see all this derivation. So one-dimensional elastic collision. The elastic or the opposite of elastic collision is inelastic collision. Inelastic collision. What is the meaning of inelastic? It is the opposite of elastic collision. Inelastic collision. In elastic collision, the bodies act like elastic body, just like rubber. The flexibility is there. Understood? No loss in kinetic energy occur in the case of elastic body. If the two rubber balls hit together, there will not be any sound. There will not be any energy loss. But if the two stones, if one stone hit the other stone, it will not be elastic. Some form of energy will be lost in the form of heat energy. Understood? The energy loss happens if the rubber ball is replaced by a two stone. One stone hit the another stone. It will not be elastic because some energy will be lost. So that's a inelastic collision. There will be loss in kinetic energy. Understood? In elastic collision, I have already discussed that. Total momentum, I have already discussed that. Total momentum is conserved. Total momentum is always conserved. Whatever may be, elastic or inelastic, is conserved. But total kinetic energy, Ke, is not conserved. Energy loss is there. Not conserved. Momentum will be conserved. Momentum is mass into velocity. That will not change. Mass into velocity before collision will be same as after collision, but energy will be lost. Heat energy, like that is inelastic collision. In our syllabus, the detail where there is no detailed explanation about inelastic collision. A special case is given in NCERT. Only the special case to be studied. Perfectly inelastic. That derivation is mentioned in the textbook. The entire thing about inelastic is not there in textbook. Perfectly inelastic. It's a special case. Perfectly inelastic collision. It is actually inelastic. Perfectly inelastic collision. Perfectly inelastic collision means maximum kinetic energy loss happens here. Maximum kinetic energy loss happens here. Momentum conserved, but in the perfectly inelastic collision, maximum kinetic energy loss in kinetic energy happens here. How the maximum loss in kinetic energy occur, I will tell you. For example, all of you please listen. There is a body here. Let me explain with the help of an example. A bullet, this is the bullet. A bullet is fired on a body, a huge body, or some body is there. A bullet is fired. What happens? What do you expect? The bullet will enter the body. Understood? You agree with me? The bullet is moving with very high speed, right? It is hitting a something like wooden object or anything, any object, whatever may be. Okay, some object, wooden. Let it be wooden object. What happens after collision? I will show you. So big sufficient width. This body has sufficient width. The bullet will enter the body. The bullet will enter the body and cover certain distance. The bullet will definitely enter the body. Think like a wooden piece having sufficient width. The bullet will enter the body, not completed. Both the body will be moving together. The body along with the bullet will be moving together. Understood? They will not be stationary. Together they will be moving with a common speed. Together they will be moving with a common speed. VC means common speed. In this case, maximum energy loss happens. So maximum energy loss happens when one body is completely embedded inside the other body and both of them moving with the same speed. In this case, the maximum energy loss occur. Why maximum energy loss? Because the bullet enter the body. During the motion there is a friction, right? During the motion of the bullet there is a lot of friction, so there is a loss in heat energy, right? There will be heat energy develop, so there is a maximum loss happens. So this is the perfectly inelastic. What do you mean by perfectly inelastic? During collision, one body completely enter inside the other body and both of them moving together with a common speed. This is the perfectly inelastic. Remember this diagram, that is better. Have you understood perfectly inelastic collision? Have you understood? Please respond.
Yes, sir.
Say Aaron, everyone okay? Devasri.
Yes, sir.
Yes, sir.
So there is a derivation. If you refer NCERT, you will see only some 2 or 3 lines. 2 or 3 steps are there. But if I write only 2 or 3 steps, you cannot understand the derivation. I will write the entire steps. So the first body, think about the bullet having mass m1. The second body has mass m2. Okay. First body is moving with the velocity say u. The second body does not move initially. After collision, the smaller one will be completely embedded inside the other body and both of them will have the common speed Vc. This is perfectly inelastic. My objective is, in exam they will ask, derive the formula for the loss in energy in perfectly inelastic collision. The question will be like that. Derive the formula of the energy loss in perfectly inelastic collision. So I am going to derive that formula, energy loss. Also I can derive the formula for the common speed. Total momentum is conserved. It is always there. Whatever may be the collision, total initial momentum equal to total final momentum. Initial momentum will be m1 into u. Momentum is mass into velocity, right? So momentum conserved. Total momentum is conserved. From that principle, initial momentum will be m1 into u. m1 into mass into velocity. m2 is stationary initially. So m2 does not have any momentum. So m1 u is the initial momentum. final momentum will be the m1 plus m2 is the single mass. Understood? M1 plus m2 is moving together. M1 plus m2 moving together. So the total mass, this entire body has the mass m1 plus m2. No loss in mass happens here. Okay. So m1 plus m2 will be the total mass. And the total mass is moving with the common velocity vc. Vc means common speed. So final momentum will be total mass into velocity. Mass is now m1 plus m2 into vc, common speed. So we get the formula for vc. Need not memorize, but in any numerical question is there, you please understand the technique. If you just equate the momentum. So common speed will be m1u by m1 plus m2. No need to memorize, but understand the derivation. Common speed in the case of inelastic collision, the common speed after collision will be m1u by m1 plus m2. Okay, all of you please remove your raised hand. If you are okay till this step, please raise your hand. If you are okay till this step, please raise your hand. Devasri Aaron understood. Raj understood. Rakshana, clear?
Yes, sir.
Said.
Yes, sir. Yes.
Okay. So I want the change loss in kinetic energy, right? Ke loss. Loss in kinetic energy will be initial kinetic energy minus final kinetic energy. I told you some energy will be lost in the form of heat energy, right? So initial total energy minus final total energy will be the loss in energy. Okay. So initial energy will be, the body has only kinetic energy. Okay. M1 has the kinetic energy half m1 u square. We studied the formula of kinetic energy, half mv square. So m1 has the kinetic energy half m1 u square. Only derivation you have to understand, no numericals. Okay, half into m1 u square. m2 is stationary, so m2 does not have any kinetic energy. This is the initial kinetic energy. Final kinetic energy will be half of half into mv square. Now the mass will be m1 plus m2. One body is completely inside the other. The mass will be m1 plus m2 vc square. Moving with the speed vc. So final kinetic energy will be half into m1 plus m2 vc square. You can take half common. You can take half common. m1 u square minus m1 plus m2 into vc square. What is this vc? Vc is the common speed. I have already derived it. Vc is the common speed. I have already derived it. Vc equal to m1 u by m1 plus m2. Correct. Vc square will be m1 u by m1 plus m2 all square, because vc square. Understood? All of you please write till this step. All of you please write till this step. If you are okay and return, raise your hand. If you are okay and return, raise your hand. You please write down one. Let me write the remaining step in the next page. Okay, there is no space here. What is the last step? Half into m1 u square, right? Half into bracket m1 u square minus m1 plus m2 After that, let me avoid one step here. Square of this one. Then numerator square by denominator square. If the square is there, we can square numerator as well as denominator. Square of numerator will be m1 square u square. m1 square u square. m1 square u square. And the square of denominator will be m1 plus m2 whole square. So what happens next? You please remove the old raised hand. 1 m1 plus m2 cancel in the numerator and denominator. Is that correct? Look here. m1 plus m2 by m1 plus m2 whole square. Can I delete? Can I cancel 1 m1 plus m2? I can cancel 1 m1 plus m2. So half into m1 u square, m1 square u square by m1 plus m2. Whatever common factor is there, you better take outside, otherwise you will have confusion. Whatever common factor is there, you better take it outside. m1 m1 square. Can I take 1 m1 outside? U square. I can take 1 u square outside. If you see any common factor, take it out. Here m1 u square is taken outside. m1 u square is taken, only 1 is remaining. Here m1 u square is taken out, 1 m1 is remaining. m1 u square is gone, 1 m1 is remaining. So it will be half into m1 u square. It is there in textbook, but only some 2 or 3 steps are given in text. You cannot understand if you read that steps. You do the cross multiplication. 1 into m1 plus m2 minus m1. You can ask me doubt after this, okay? Okay, yes. So what happens next? What happens next? It will be half of m1 u square into 1 m1 cancel here, m2 by m1 plus m2. Got the answer? You may write 1 by 2 m1 m2 by m1 plus m2. U square is the loss in kinetic energy. Just understand the derivation. No numerical given in textbook. In the case of perfectly inelastic collision, the loss in kinetic energy will be half into m1 m2 by m1 plus m2 into u square. All of you please write down. If you are okay, raise your hand. If you are okay and written, raise your hand. Say the Aaron Devasri understood. Rakshana okay. All of it clear. All this question I have already discussed. So one more theory. Only theory type question will be asked. Don't worry. Then another, this is the last topic in this chapter, okay? The collision is over. One more topic is there. One more thing is there. Two-dimensional. Only theory question will be asked. Don't worry. Only theory question will be asked. Two-dimensional elastic collision. Two-dimensional elastic. We are talking about elastic body. Elastic means no loss in energy. Two-dimensional elastic means that, all of you please listen. There is a body M1 and there is another body M2. Not straight collision. If it is straight, the two bodies will be moving along straight line. Not head-on collision. Head-on means not hitting the middle point. The body is not hitting the middle point. Instead of that, slightly, not exactly horizontal, a small angle, but it is the bodies act like a point-like body. The bodies look like a point-like body. So this collision line, this line is, making a small angle with the horizontal, maybe 0.1 degree or 0.2 degree like that. A very small angle, understood. So not exactly at the middle. It is hitting the second body, not exactly at the middle, a corner of the body. What happens after collision? Let me draw a line, horizontal line. The yellow colored one make a extremely small angle, 0.1 degree or 0.2 degree. We approximate it as 0 degree, okay? After collision, what happens is M1 will be moving in one direction and M2 will be moving in another direction with a different speeds. Say V1, let it be V2. M1 approaches towards M2 with the initial speed U, but after collision, both of them are not moving along a line. They have different directions. So this type of collision is two-dimensional collision. Elastic, I am talking about elastic type, no loss in energy. Rubber ball. When somebody talking about elastic, think about a rubber ball. Okay. Have you understood till this step? Is that okay? Is that okay? Okay. So only 3 sets of equation to be written. No numericals. Don't worry. No numerical because it is highly complicated. If the numerical question is asked, it will be extremely difficult. There is no question in textbook exercise. So only theory part only you have to understand. Theory part only, okay? Because there are plenty of terms associated with this type of motion. Here, the first body will be making some angle θ1 with the horizontal direction. The second body will be making some angle θ2 with the horizontal direction, right? So there will be 3 sets of equations. One is, since it is elastic, total momentum is conserved. Total horizontal momentum. Let me convert. Momentum is a vector quantity. It has the horizontal direction as well as vertical direction. Total horizontal. Let me write the equation. After that you can ask me it out. Total horizontal momentum is conserved. Total momentum in the horizontal direction is conserved. Meaning that horizontal means forward direction. M1 is moving with the horizontal speed. I told you that U is almost horizontal. Maybe making some 0.1 degree or 0.2 degree. We neglect it. M1 is almost moving horizontally with the speed U. So initial momentum, mass into velocity, M1U. Before collision, the net horizontal momentum will be M1U. In the after collision horizontal momentum, V1 is the velocity of M1. You know that V1 has 2 components. V1 has 2 components. V1 has 2 components. One horizontal component is said to be V1 cos theta, and the vertical component is said to be, we have already studied that, v1 sine theta. Since they are vector quantity, the horizontal and vertical components are considered. v1 is an inclined speed velocity, so v1 has the initial horizontal component. In the horizontal direction, I mean shadow, m1 is moving like this, the shadow is appeared to be moving with the speed v1 cos theta. Horizontal shadow moving with the speed v1 cos theta, vertical shadow moving with the speed v1 sin theta. So after collision, I will interact with you, but let me write the equation. After collision, m1 has the horizontal velocity v1 cos theta. So m1 has the momentum m1 into v1 cos theta. Mass into velocity m1 into v1 cos theta is the horizontal momentum of m1, plus it is in the positive direction. m2 also has horizontal and vertical components. v2 has horizontal component in the same way v2 has the horizontal component v2 cos theta 2. Oh, here theta 1, here theta 2. Okay, v2 cos theta 2 is the horizontal component, and v2 sin theta 2. v2 sin theta 2 is the vertical component. It will be asked as a theory question. So m2 has the horizontal component v2 cos theta 2. So m2 has the horizontal momentum m2 into v2 cos theta 2. If it is asked as a theory question, you have to draw the diagram. Only 3 sets of equation to be written. That's all. Okay, 3 sets of equation you will get. I got 1 equation. All of you please draw the diagram and write the first equation. Till this step, not finished yet. Till this step, if you have any doubt, please ask. Till this step. If you are okay and written, raise your hand. Devasri understood. By today's class, this chapter is over. Okay, Aaron okay, Rakshana okay, Said okay. Momentum is a vector quantity. Total horizontal momentum conserved. Similarly, total vertical momentum is also conserved. Total vertical momentum is conserved. Vertical means along y-axis. m1 u does not have any vertical components. U is moving in the horizontal direction. m1 is moving almost in the horizontal direction. m1 does not have any vertical component. m1 is almost moving horizontally. So initial momentum 0, because m1 does not have any vertical velocity. Is m1 has a tendency to move upward? No, m1 moving in the horizontal direction only, no vertical component. So in the vertical direction, no momentum. In vertical direction, no velocity, so vertically no momentum. m1 does not have any vertical momentum, m2 also no momentum. In the right side, vertical momentum. m1 is moving upward. m1 has the vertical velocity v1 sin theta 1. m1 has the vertical velocity v1 sin theta 1. So m1 has the vertical momentum m1 into v1 sin theta 1. Mass into velocity. And m2 has the downward momentum. If the velocity is downward, we have to put a negative sign. If the velocity upward, positive sign. Sign convention is there for velocity. If the velocity is downward, we have to put a negative sign. So m2 into v2 sin theta 2, but we have to put a negative sign because velocity is a vector component, vector quantity. So minus m2 v2 sine theta 2 plus minus, okay, or minus, no problem. So I will repeat, m1 does not have any vertical velocity, so initial vertical momentum 0. Final vertical momentum means m1 has the vertical velocity v1 sine theta 1. So m1 has the momentum m1 v1 sine theta 1. m2 has the velocity minus v2 sine theta 2 downward. So m2 has the momentum m2 minus m2 v2 sine theta 2. Clear? All of it clear?
Yes, sir.
And finally, 3 sets of equation you will get. Total kinetic energy is conserved. Last equation. Initial total kinetic energy half into m1 u square. You agree with me? m1 is moving with the velocity u, so kinetic energy of m1 will be half into m1 u square. It is the initial kinetic energy. Final kinetic energy. For kinetic energy, we don't need components. We don't need component. Direction is not considered. m1 is moving with the speed v1. Can I say like that? m1 is moving with the speed v1. So m1 has the kinetic energy half m1 v1 square. For kinetic energy, direction is not required. m2 is moving with the speed v2. So m2 has the kinetic energy half m2 v2 square. Later you may remove half. Not necessary. Both sides you can remove half. So 3 sets of equations you will get. From these equations, some letters are, if some letters will be given, you can find out another, so theta 1, theta 2, v1 will be given, you have to find out v2. Yes, by substituting the given value in the 3 equations. By substituting the given values in the 3 equations, you can find the unknown value. But no numerical will be asked because there is a lot of letters, terms in this formula. So you cannot expect, you will not, there is no numerical question based on this. So only 3 sets of equation to be written. That's all. So this is about 2-dimensional elastic collision. Okay. All of you please write down. If you are okay and written, raise your hand. Devasri, Aaron, Rakshana, say the okay. So let me wind up the class.